Hello everyone, hope you're doing well. In the next part of the question about best time to buy and sell, today we'll cover the next scenario of this question, and let's discuss that. What the difference between the previous question that we solved versus this one. So if you remember in the previous question, the first part of best time to buy and sell, we covered that we can only buy once and we can only sell once. In this one, we can buy and sell as many times we want. At the same time, so this condition is kind of relaxed that yeah, we can buy and sell as many times we want. At the same time, at this, we can't have more than one stock, so we can only have at most one stock. So if we want to buy a new stock, we got to sell it first. So buy sell should be the sequence. We can't buy new stock unless we sold the previous one, because we can't have more than one stock at the same time. So with that variation, anyway, at most stock was the even case was the previous example as well. The only difference that if you notice is that in the previous example we can only buy once and sell once. Here we can buy and sell as many times we wanted. We have taken the same example to simplify or to understand. So if you have not watched the previous video, please go and watch. The title is best time to buy and sell stocks, part one. So let's take this as example, right? 715364. So if you remember the previous time, the previous, example, we got output 5 because we could only do, I think, we can only buy and sell one. So we bought when it was 1 day, and of course we sold when it was 6. So 6 minus 1 equal to 5. In this case, because we can do buy and sell as many times we want, the output is our maximum profit is 7, not 5. How it's 7? Because let's say, let's take an example that we bought on day 2, that is price 1. We sold again on day 3. We got a price 5, so we got a profit 4. 5 minus 1, 4. Again, since we sold on day 3, we can again buy, and we bought on day 4 with a price 3, and we again sold on, we can again we can sell on day 5 with the price 6. So again, we got a profit 3 here. 6 minus 3. So overall profit 4 plus 3 equal to 7. So the profit increased because we can do this transaction more than one time. Again, second example, no difference because there, the price is kind of reducing. So it's like we generally prefer the price increased for sell. So in this case, we could not, buy, or if we bought, we can't sell. So in this case, we could not do the complete transaction, and we are returning profit 0. Okay. So let's talk about the approaches that we are going to take. So first one, of course, we will take a rudimentary approach with a recursion. In this example, we can think about recursion because we need to go in, I would say, we need to try different options, right? Here, buy and sell. So recursion comes first in mind. So first approach we'll see. The only problem it has is that it has this, the time complexity 2 of n, that is not good. And this is because it has overlapping subproblems. So there are a lot of overlap on the data. We tried to optimize it with a better approach with a recursion, of course, but we added a memorization feature or memorization technique by adding a few variables to not do the calculation again for the, for the cases where we already kind of traversed through. So time complexity got better, close to ON. Again, space complexity again ON in both the cases. We again further went to the efficient approach possible with the tabulation approach, where time complexity is still ON, of course, a little better than the previous one, but space complexity is constant basically. So that's great. So we are saving a lot of space. So without further delay, let's go. And again, the code would be here, so in case you want to play around later, you can do that. Let's quickly go to the code and we'll hit that. So let's take this example. We'll try to, for the simplicity's sake, we'll try to focus on the core logic than the logic that is the that you can anyway type yourself. So in this case, we have taken the same example basically. So let's take example first to begin with. We'll create a method called max profit one. So let's create it. Yeah. So we created this one. We can return profit. We can make it integer here. Let's try to code this. So we took the same example as we showed in the PPT to make it easier to understand. Now let's take, so we'll the first approach we'll go with the thing that we discussed, the brute force one with the recursion and plain vanilla. There is no optimization there. The first thing that comes to your mind. Okay, so let's see that how that works. So again, we'll focus on the core logic. So we'll create a this one. So since we told that we'll create a, I would say, recursion there. Okay, so for recursion we need to first create a, we need to call it, and of course it will go on and on until this the condition is qualified, right? I hope all of you understand the recursion basics. Okay, so we'll create a one private method. For that, let's name it get max profit. Okay, yeah, and now what we'll do, well, to save time, I have edited a sample so that we discuss on this, we understand the code logic instead of typing a lot of code. So but try to understand it. So again, we have taken two variables here. In idx keeps the index because we need to traverse through. By is again a variable that we will be using it here. Basically, buy represent that you can buy, right? Whether you are allowed to buy, and we'll be representing buy with one, like zero. With zero means if buy is zero, it means you can't buy. If it is one, then of course you can buy, and you can only buy if you're not already have some stocks. We need to sell it first in case you're buying. So buy will have zero or one. Price is again the same array that basically we'll get from here, and n is for traversal, right? So since it is recursion, so we need to have all these variables. Okay, so let's see this code and then we'll discuss it. We'll try to explain this, how this works. Okay, so again, until the index touches n, because index will be keep increasing. So it's a typical code, right? That if it is n, of course we'll return 0 and we'll close this. Okay, we've taken one variable called max profit for to basically to keep the profit. Again, I told that buy equal to 1 means we are going to buy, or we are eligible to buy. So if we are buying, of course we are we lose out the money, right? So that's where you see the max of this one. So price will be reduced. So minus prices on the same index that we are in, plus this will again be called, right? It is a recursion. So we are saying that this plus, of course, the profit on the next index, because it will be keep going, keep traversing, right? So idx plus 1. And again, if we bought here, see, if it is bought, of course we can't buy again. So the buy is 0 here, right? The buy will be 0 here, right? Because we already bought here. Price again will pass the same and is same. So again, if we bought it, so there are two cases, right? If either we bought it or not, like didn't buy. So if we bought, of course, the price will be reduced. Let's say we have chose not to buy. So in this case, we are not using any money, so it's a 0. And since we did not buy, so of course, we can buy again. So same function will be called again for a next index. Here again, if you see, this is one. This one means basically you can still buy one more time, right? Because you did not buy here. In the previous example, it is 0 because you already bought here. So you can't do both, right? Here since you choose not to buy, so you can buy again here one. Again, the same variable prices and n. So that was the case when we are having the condition of buy. If it is, let's say we are not buying, right? So if we are not buying, so it means we are selling. So again, we can choose to sell and choose not to sell on any given day. So let's say we are, what's the max profit? Max profit is that we are selling it. So prices of the same on the same index. If you are selling, of course, we can buy again. So get profit, or it will be called. We can buy again. So again, the here, if you see, it is again one here after the next index, and there's no change. If we choose to sell, then this is the one. If we choose not to sell, then of course we will have the 0. We have not gained anything there, and we have choose not to sell means we can't buy, basically we still have it. So hence this variable is 0 here. So this is 0 here. So it means we can't, because we didn't sell, right? So there are two cases. Either if you're buying, so either you are buying, choose to buy, or not choose to buy. If you are selling, so that we are selling or not selling, right? So there are two cases. So this the only thing is with this is that there could be let's basically call this recursion method again, right? So if you're calling, so initially it will be like, let's see, yeah. So this we call like initially it will be like index 0. We are going with the attention of buying, so buying is one here. And let's keep the same, I would say, variable. So instead of having different, we can keep same. So same array, and of course this length, n is length, right? So it's pretty simple. So now with this, let's see, I think we have coded in this case, basically we're doing recursion until we touch the n, and whether it's, let's see this working or not. So I'll run this. Yeah, it is there. Let's see this, whether we are getting 7 or not. Okay, there's some build error, we'll fix it. Okay, we missed this one, braces. It should work this time. So one thing is, difference than the previous example is that here you have cases where you need to, since you can buy and sell as many times as you wanted. See, it is savings is working. So you need to kind of code for these two cases, as we discussed here. So it was a recursion, but however it is, if you notice, it will, until this n is there, it will be there for, so there are, there are a lot of overlap data that will happen. So how to make it better? So to make it better, we need to do few things. So what we'll do is that we'll not touch it. We'll create a maybe another example of that, right? And then we'll see that what's the difference. So we'll use the memorization technique that we spoke. So now here we'll say 2, and then we'll create one more method for it. Yes, not rename, create a new one. So we'll create a new one here, and we'll keep it the same name for simplicity, prices. And let's create one more private, I would say, variable, because it will be used. We'll say get max profit 2, like that we had max profit 1, so we'll make it max profit 2. Notice what changes we're going to do that, right? So what we'll do, we'll keep one list actually to have the, to store the state of the previous one, so that we're not calculating we are keeping the previous state, and we are if it is already there, we are just returning it. We are not going again traversing. So we'll save some CPU cycle, and in turn it will be faster. Okay, so for that, let's see the difference, and I'll talk about the core logic that is kind of playing, that is adding to this, I would say, efficiency from the previous one that we had. So if you now we compare the code as well, so not much changes. If it is let's first write the code and then we'll discuss it. So for that, we'll take one list of lists because it is an array, and we'll keep the state. Uh, we'll keep the state, and then we'll see how this works. So yeah, so we have taken list of lists. This again we are taking little plus one actually than this to store the additional the counter. Again, we're just instantiating this one with -1, right? And we are again, if you notice, we just had till this in the previous one. Now we have one more list. Okay, so see again list here, right? Just to keep this that we already traverse and we are not traversing again. Okay, so just for that. Now notice the changes. So no change here. It was there in the previous one as well. This is the one that is doing the job. So if it is not -1, means it this state already traversed, right? We did a calculation. Then we're just returning it. We are not going again further for this. So number of calls are getting reduced, right? No change here. If you notice, no change here, exactly same. Only thing is we added list here, rest all is same, right? The previous, like, two conditions, buy, and then again whether we are buying or not buying. If we are selling, then two conditions again, whether we are selling or not selling. The one thing that we have again slight changes here. So instead of returning max profit that you were doing in the last, if you notice here, max profit, right, you were returning, what we're doing is that also store the max profit into this particular index or position, right? So list of index against that, and what is the whatever the buy that we have, against that we are storing the maximum profit, right? So it is storing, and hence we are able to check if it is -1. If it is not -1, means it's already stored here. So quickly return it. Let's not go further, right? Now I hope you're able to understand that how this and this is related, and due to that we are able to save some CPU cycles and more efficient. So it is now not 2 to the power n, it's just I would say it is going 0 to n minus 1 kind of. So it is on. So the time complexity almost like reduced from, or got better from 2 to the power n to on. That's a good because of this only, right? Because we are not going again to the traversal which already kind of gone, which are already executed, right? So that's why you're able to save time. Now let's see whether it's working or not. So what we'll do is we'll make it already, we made 2. Now let's see whether we are getting 7 or not. Okay. Oh, we are getting good. So this is also working. So we improved on the time complexity. Now if you notice, there are some state, and we can do better even with these, right? The listed object are like container objects have a space complexity, so we can do better. So we'll try to do better again. So to make it better, let's say create a third one. We'll create one more. The third one, if you remember, we discussed about 3 approaches here. So we covered the first and second approach. Now we're talking about the most efficient approach, the tabulation one. So now we'll not have recursion. We'll have the tabulation there. Okay. So let's see. Now what we'll do is that in this one, okay, it changed. Okay, we don't need to. We'll get a new one basically. We'll not touch it, not rename, generate a new one. So we'll make it integer, and we'll clear it. So this time we don't need a 2 method, because in tabulation we can just live with in one. In recursion you need one for calling, one for executing, right? So for that, let's see how the logic is also simplified in the tabulation, right? So this is the most efficient code. What we have done is, let's understand the intuition and understanding. So what we have done is that We created four variables instead of having these list objects. We created four variables. Uh, not by. So we have taken two pointers basically, current and ahead. So not by, and like one for current not by and one for current by. If you remember, there were four cases, right? By, not by, and one for next day basically, like next index. Ahead we are saying is, so ahead not by, and ahead by. We can call it ahead, we can call it next, whatever we would like to say, right? So anything we can call it. Let's say we are calling next because it's more simple to understand. Yeah. Okay. So we'll get and the logic is simplified. So in this case we are not using any additional list and all, so we are able to save space as well. Space complexity is also in constant terms. So let's see and understand the core logic. Okay. So no changes. I'll make it same name to avoid any confusion. So let's keep it prices. So n is same, no change. As we discussed that I've taken four variables, current and next. Current and next are, if you want to understand which are they. So if you notice in the previous example, we were using something similar. So this is for next, right? This was current, IDX, this was next. So we're trying to mimic that logic into the tabulation form. Okay, so that's how the current and next is coming. Now by and not by, how is coming? By equal to 1 means by equal to 0 means not by. So we are just transporting that logic into the tabular format. Okay, so there is no new logic, rather we're just transporting into the tabular form to make it more even simpler. Again, it is going on, of course, and ns1 to 0, no change here. Now again max, no change. Price of this, and uh, if we are basically not buying, so we can buy again. So that's why it is 0, right? And if you and next not buy. So if you can buy again. Second is that if we are not, basically let's understand one more time. So if we are not buying right now, right? So if you're not buying means we are selling, right? Uh, or we can reverse this to make it even easier. Let's put it this first because it is how the loop we had, right? First we had for buy. So let's say we are buying it. If you're buying it, so we are expending some money. So price, it is reduced from this one, right? And if we are buying it, so of course next we can't buy, right? Well, we can't buy again since we have bought again. If we can't buy, so of course we are saying this 0, right? And of course that's how we can do that. So again here it should not be, I would say, we can see even this, we can say next not ahead to avoid confusion. Yeah, next buy. So if you're buying, we'll reduce the money from here. And again, since we bought, we can't buy because we need to sell first, right? And if we can't buy, so of course next we can buy. If we are not buying, right? So we are selling, and if we are selling, we'll get some money. It's positive, and of course next we can buy because we just sold it, right? That's how it is. And we can buy. So further next week, of course, we can't buy. So that's how the cycle goes. And again, the current will be typical to any loop, right? If you folks remember in the queue and all, also we do like this. So current will be stored into the next, and current not buy will be stored to the next not buy. And in this one, to give this array going, we can return to the in the last, we can return until this is 0, we can return the next by whatever is there is the maximum profit that we're looking for, right? So we have transported this logic, the previous recursion logic, into the tabular form. Let's see if it is working or not. So 3, we're calling 3. Let's see how the code got simplified, right? You can hardly count how many lines we have. So now let's see whether it's working or not. Okay. Yeah, it's working. So we are, getting 7. Now let's try one more example that we had, that we were talking about in the questions that when we discussed, we had 7, 6, 4, 3, 1, whether we are getting 0 or not. 7, 6, 4, 3, 1. Okay. So we'll say 7, 6, 4, 3, 1. We should be getting 0 this time. Let's see. Yeah, we're getting 0. So it's working, folks. These were the logic. That's how you can, code for the case where you can, basically the second part of this, where you can buy and sell as many times you wanted. Okay, so we'll bring to 3 cases just to summarize. So the last one is the most efficient one. Since we are using variables, without any extra containers, we are able to have space complexity at O1. Time complexity remains the same O(n), right? We look into demo. Again, as I said, the code is available over here. Thanks to this platform, which gives us with amazing questions to play around with. This is a bit about me. Again, if you want to be notified, you may want to subscribe. Thanks for your time. Take care.